Hi, welcome to my channel Smart EC. Today I'll explain one simple problem how to design a Chebyshev IAR digital low pass filter by using bilinear transformation. Yesterday already I explained the procedural steps how to design the filter using bilinear transformation. Today we'll see with the help of one simple example. Let us see the problem. Design a Chebyshev IAR digital low pass filter to satisfy the following constraints. The constraints are given as here 0.707 is less than or equal to magnitude of h of omega is less than or equal to 1 over the frequency range 0 to 0.2 pi, and the magnitude h of omega is less than or equal to 0.1 over the frequency range 0.5 pi is less than or equal to omega and is less than or equal to pi using a bilinear transformation, and assume t equal to 1 second. So first we have to write the given data. From the problem statement we can conclude that the passband gain A1 equal to 0.707 with the passband frequency 0.2 pi, and stopband gain is A2 which is 0.1 with the stopband frequency omega 2 which is 0.5 pi, and given that t equal to 1 second and bilinear transformation is used. We'll follow the procedural steps. Step 1, here we have to choose the type of transformation, and already I told you in the problem itself it mentioned that bilinear transformation is to be used. In step 2, calculate the attenuation constant alpha, where the formula for alpha is 1 by a1 square minus 1 whole power half, and here's given that a1 which is equal to 0.707 minus 1 whole power half which is equal to 1. Step number 3, here calculate the ratio of analog edge frequencies omega 2 by omega 1, and here omega 2 by omega 1 we use, as all of you know that we are using here bilinear transformation. Here the formula for bilinear transformation for calculating the analog frequencies omega 2 by t tan omega 2 by omega 1 for omega 2 and 2 by t tan omega 1 by 2 for omega 1. So cancelling these two parameters we are left with the tan of 0.5 pi by 2 divided by tan of 0.2 pi by 2. After simplifying you will be getting the ratio of analog edge frequencies which will be 3.0779. And the step number 4, we have to find the order of the filter n. Here using the formula n is greater than or equal to cos h inverse 1 by alpha into 1 by a2 square minus 1 whole power half divided by cos h inverse omega 2 by omega 1. After substituting all the values and simplifying, here we will be getting the value of n which is greater than or equal to 1.669, and all of you know that we have to choose the value of n such that it should be an integer higher or equal to this value obtained from this simplification. So the nearest higher integer value for 1.669 which is equal to 2. So we have to choose the order of the filter which is equal to 2, which is an even number. Next we'll move on to the step number 5. We have to calculate the analog cutoff frequency omega c, and omega c equal to omega 1 by a1 square minus 1 whole power 1 by 2n. After substituting these values we will be getting the analog cutoff frequency omega c which is equal to 0.6498. Step number 6, we have to calculate the analog filter transfer function HA of S. Here the calculation of this HA of S which involve lot of coefficients. First we will try to see the actual formula for HA of S which is equal to k is ranging from 1 to n by 2 bk omega c square by s square plus bk omega cs plus ck into omega c square which is equal to b1. As all of you know, here the order of the filter n equal to 2, so 2 by 2 is 1, so k is ranging from 1 to 1, therefore the value of k equal to 1. After substituting the value of k equal to 1 over here, b1 omega c square by s square plus b1 omega c s plus c1 into omega c square. So for computing the coefficients bk or this bk and ck, we have to compute the another important parameter or the value which is nothing but a yn. The formula for yn is 1 by 2. Here 1 by alpha 1 square plus 1 whole power half plus 1 by alpha whole power 1 by n minus 1 by alpha square plus 1 whole power half plus 1 by alpha whole power minus 1 by n. And we know that we got the value of alpha which is equal to 1. After substituting all the values and simplifying, we will be getting the value of this yn which is equal to 0.455. And another coefficient we have to find out, that is b1. The formula for b1 is 2yn sine of 2k minus 1 into pi by 2n. Substituting these values, we will be getting the value of b1 equal to 0.6435. And another coefficient ck, I mean here the value of k equal to 1, c1 equal to yn square plus cos square into 2k minus 1 into pi by 2n. Substituting this all the values, here we got 0.707. And for n equal to even, here we will be using another formula to find this capital bk values. K equal to 1 to n by 2, bk by ck which is equal to 1 by 1 plus alpha square whole power half which is equal to 0.707. Simplify, substituting this value of alpha here, we will be getting this entire 1 by 1 plus alpha square whole power half will be equivalent to 0.707. And we know bk by ck which is equal to 0.707 and bk, I mean k equal to 1, b1 equal to 0.707 into c1. And here we got the value of c1 equal to 0.707, that is multiplied with this 0.707 will be having approximately 0.5 value. After getting all the coefficients, all the values, substituting all the values yn, b1, c1, bk in the analog filter transfer function. Therefore, the system function is written as HA of s, which is something but 0.5 into 0.6498 whole square by s square plus 0.6435 into 0.6498 into s plus 0.707 into 0.6498 whole square. After simplifying, we get HA of s. This is analog filter transfer function, which is nothing but 0.2111 divided by s square plus 0.4181 s plus 0.2985. Now step number 6. Using bilinear transformation, we have to transform the analog filter transfer function HA of s into a digital filter transfer function H of z by using bilinear transformation. As all of you know, this is the procedure for transforming HA of s into H of z using bilinear transformation. Simply substitute in place of s 2 by t into 1 minus z power minus 1 by 1 plus z power minus 1. So wherever you have a s here, s square, or in place of s, substitute 2 by t into 1 minus z power minus 1 by 1 plus z power minus 1. As all of you know, we are assuming that t equal to 1. Therefore, here the transfer function is 0.2111 divided by s square plus 0.4181 s plus 0.2985. And here we have to substitute s equal to 2 into 1 minus z power minus 1 by 1 plus z power minus 1. Here in place of s square, substitute this. In place of s, we have to substitute this 2 into 1 minus z power minus 1 1 plus z power minus 1. After simplifying all the terms, finally we have the transfer function of h of z in terms of z, which is equal to 0.0411 into 1 plus z power minus 1 whole square by 1 minus 1.441 into z power minus 1 plus 0.6744 into z power minus 2, which is the desired filter transfer function h of z. Thank you for watching my channel. For more updates, please subscribe to my channel. Thank you.